In 2026, lunar exploration has reached a historic turning point. SpaceX's Starship continues to push technical boundaries as Elon Musk and his team work to normalize heavy-lift, fully reusable space transport. Meanwhile, NASA's Artemis program and the Sino-Russian International Lunar Research Station, ILRS, are racing toward the lunar South Pole. Global attention is fixed, like never before, on the water ice hidden within the permanently shadowed regions. We are witnessing a global paradigm shift. Space is no longer just a destination for short-term scientific research, but an extension of our industrial supply chain. International strategies are pivoting from temporary outposts toward the first stages of in-situ resource utilization, ISRU. Yet, beyond these disparate missions lies a more profound question for planners. If the moon is destined to be humanity's first strategic outpost for deep space, what is the underlying logic for building a true lunar city, one capable of sustaining interplanetary logistics and industrial production? Is it merely a collection of drilling stations scattered across the South Pole? Today, we are stripping away the sci-fi lens. Grounded in geography, energy, and engineering logic, we will map out a viable roadmap for the evolution of lunar civilization. To plan a lunar city, we must first define its underlying logic within the framework of interstellar navigation. With no atmosphere and no magnetosphere, the moon is hardly an ideal final destination for human settlement. However, its strategic significance is absolute, dictated by the laws of physics. First of all, the gravitational advantage. The moon's gravity is only 1/6 of Earth's, 1/6 g, which means a significantly lower escape velocity. Launching the same payload from the lunar surface requires only a fraction of the propellant needed on Earth. In addition, the strategic location. At just 1.3 light-seconds from Earth, the moon is the ultimate resupply station, freeport, and heavy industrial shipyard for deep space exploration. Therefore, the essence of a lunar city is not migration, but the establishment of an efficient, extraterrestrial industrial supply chain. The moon's true function is to serve as a deep space logistics hub, a propellant depot, and humanity's first extraterrestrial heavy industrial park. Under this paradigm, the lunar city is built for production, not consumption. First, propellants. Liquid hydrogen and liquid oxygen, harvested through the electrolysis of lunar water ice, will become the lifeblood of interstellar travel. Second, heavy components. By leveraging the moon's abundant ilmenite and its absolute vacuum, we can 3D print spacecraft hulls hundreds of meters long directly on the surface. These massive structures could never withstand a launch from Earth, but from the moon, they can simply glide into the deep void. Once our strategic goals are set, we have to find where they actually fit on this desolate map. In urban planning, form follows function, but on the moon, form is dictated by survival. Our site analysis reveals a brutal geographic reality. First, we look at the North and South Poles. The value here is unparalleled, high-frequency sunlight and crater-bottom water ice. In a vacuum, sunlight is our only reliable power source. Water ice is even more critical. It is the foundation for all extraterrestrial life. By electrolyzing this ice, we produce oxygen for breathing, water for drinking, and the ultimate propellant for interstellar travel, liquid hydrogen and liquid oxygen, LH2/LOX. The poles are essentially the moon's oil fields and reservoirs. However, the polar terrain is incredibly rugged. Worse, there is no large-scale natural shielding. On the lunar surface, there is no atmosphere to block lethal cosmic radiation or the constant rain of high-velocity micrometeorites. Building in the open means a massive spike in maintenance costs and a constant risk to life. The conclusion is clear: the poles are our lifeline, but they are too confined and exposed for massive heavy industry. Next, we turn to the lunar marea near the equator. The surface is vast and flat, but the environment is unforgiving, defined by 14-day-long freezing nights. Yet, beneath these plains lies nature's greatest gift to humanity: giant lunar lava tubes. Latest data suggests these underground voids are massive, far beyond anything on Earth. They are typically over 1,600 feet wide and up to 1,000 feet high. That is wide enough to fit 10 highway lanes side by side, or tall enough to house an entire skyscraper. More importantly, these tubes are capped by 130 to 330 feet of solid basalt rock. This is a perfect natural shield, maintaining a constant internal temperature of about -4 degrees Fahrenheit. This extreme geographic mismatch forces us to abandon the dream of a single, centralized city. Instead, we must build a dual-city network spanning over 1,800 miles. The first pillar is the polar refinery. Located at the poles, its core function is energy harvesting and fluid extraction. It harnesses nearly continuous solar power to mine crater ice, converting it into high-value fuel on-site. The design is purely utilitarian. Core facilities are semi-buried under lunar regolith for radiation protection. On the surface, a forest of thousands of solar towers and automated drills defines the landscape. The second pillar is the equatorial forge, hidden deep within the lava tubes. This is our hub for heavy spacecraft manufacturing and advanced materials processing. Within the vast, stable spans of these basaltic caverns, we can assemble 100-ton starships directly underground. Because the rock provides a natural shield, these factories don't need heavy, armored shells. The architecture consists of lightweight, pressurized modules nested directly into the ancient rock walls. By trading geological structure for industrial space, we make large-scale interstellar assembly a reality. Because our resource sources and manufacturing hubs are physically miles apart, building this system requires a rigorous engineering sequence. We cannot build a city overnight. We must evolve it through a series of tactical phases. Phase 1 is the polar cold start. The first, seed factories, arriving from Earth will land exclusively at the peaks of eternal light near the poles. In these early days, energy is the only priority. Only here, with near-constant sunlight, can our machines survive and begin the process of self-replication. Using 3D printing and local regolith, these initial modules will manufacture their own spare parts and expand their solar arrays, achieving the first stage of industrial autonomy. Phase 2 involves the ballistic cargo system. In the early stages, we won't have the luxury of expensive, long-distance tracks. Instead, the polar refinery will deploy electromagnetic railguns. These will launch standardized fuel canisters and refined metal ingots toward the equatorial forge, thousands of miles away, like a precision shot put. Because there is no air resistance on the Moon, these cargo pods will follow a perfect ballistic trajectory, landing accurately at receiving fields near the equator. This low-cost, one-way delivery system will provide the raw materials needed for the equatorial forge to begin its own cold start. Phase 3, the maglev artery. As our industrial capacity matures, the need for two-way transport of personnel and delicate equipment will trigger the second stage of expansion. We will construct a semi-buried maglev network. By laying the tracks in shallow trenches and covering them with lunar soil, we solve the two greatest engineering headaches on the Moon: the massive thermal expansion caused by 540 degrees Fahrenheit temperature swings and the constant threat of micrometeorites. This vacuum-sealed maglev will allow for high-speed, frictionless travel between the poles and the equator. The final phase, the interstellar mass driver. Ultimately, starships assembled in the massive underground lava tubes will be transported to the system's terminal, the interstellar electromagnetic catapult. This massive rail will be built along the natural, miles-long slope of a crater rim, stretching toward the stars. By using electromagnetic force to provide the initial launch velocity, the ship can reach escape velocity without burning a single drop of its own fuel. In this moment, the Moon officially transitions from a self-sufficient outpost to the primary launch pad for humanity's expansion into the deep cosmos. As this planetary-scale production network begins to hum, the final and most critical question emerges. Where will humanity actually live? In this lunar industrial landscape, we will adopt a mothership and outpost model. The North and South poles will function much like offshore oil rigs, highly automated, high-stress environments manned by skeleton crews of technicians on short-term rotations. But the true home of lunar civilization will be built deep within the equatorial lava tubes. This choice is driven by more than just survival. It is driven by psychological health. To understand life here, we must abandon Earth's two-dimensional maps. In a cavern 1,000 feet high with only 1/6 gravity, the city evolves into a three-dimensional vertical lattice. The industrial substrate at the very bottom is anchored to the cavern floor, where maglev terminals and heavy machinery operate, keeping all vibration and noise locked away. Above them, the residential mesh, a network of pressurized modular pods, is bolted directly into the ancient basalt walls, hundreds of feet above the floor. This elevation provides not only absolute quiet but also the permanent radiation shield of over 100 feet of natural rock. A citizen's day begins in one of these wall-mounted pods. In 1/6 gravity, waking up is no longer a struggle against weight, but a graceful, effortless leap. By 9 a.m., you take a vertical transit pod to the mid-level command center. You don't need to physically travel to the poles, you simply step into a VR suite. With a near-zero latency of just 0.01 seconds, you teleoperate robotic swarms at the North Pole, 1,800 miles away. You sit in a climate-controlled, safe office, yet you feel every vibration as the polar drills bite into the ice. In the afternoon, you head to the highest point of the city, the Sky Commons. This is the green lung, suspended from the vault of the ceiling. The vertical farms here produce oxygen filled with the scent of damp earth, a vital psychological break from the sterile, mechanical world below. After work, you strap on a pair of lightweight wings. In the 1,600-foot wide cavern, your own muscle power is enough to let you soar through the air. In this world, gravity is no longer a shackle, it is a new dimension of freedom. This is no longer a fragile, isolated laboratory on a dead rock. It is a robust, subterranean civilization rooted deep into the Moon's geology. It is built on the logic of the Earth, but perfected for the physics of the Moon. Humanity has finally found its footing and its launch pad among the stars.